Okay, we're going to look at a couple of limit problems from our second part of 1.3. And each of these we're going to have to do some kind of algebraic manipulation in order to determine the limit. And the reason is because in each one of these cases, in applying our limit laws, we would end up with 0 over 0 in all three cases, which we know that to be indeterminate. So here for the first one, we know, and again, whenever we get 0 over 0, that we do have a factor in common between the numerator and denominator. So a couple of ways to attack the first one. One is if you recognize how to factor the sum of, or difference rather, of cubes, you would know that the denominator factors into x minus 2 and x squared plus 2x plus 4. Now, not everybody remembers how to factor the difference or sum of cubes. So you know here, again, because x minus 2 is a factor, then you could do division in order to determine that other factor. You could do long division or you could do synthetic. So if we did synthetic division, the root associated with that factor is a 2. Then we use our coefficient of x cubed is 1. We have zeros for x squared, x to the first, and then we have our constant term. And going back in a little review, right, we bring down the 1, multiply, add, multiply, add, multiply, add. And here's our remainder. And since 0 is a remainder, that does confirm that 2 is a root and x minus 2 is a factor. And since that's x cubed, each one of these down here will be 1 degree less. That's our x to the 0 or constant term, which is how we get the x squared plus 2x plus 4. So anytime you're having difficulty factoring, you could do some kind of division, long or synthetic. In this case, because we have a first degree divisor, we can use synthetic division. All right, so going back up here, we notice again we have that factor in common. So that divides out, that is divided, x minus 2 divided x minus 2 is 1. So now we have the limit as x approaches 2 of 1 over x squared plus 2x plus 4. And so we know that would equal 1 over 2 squared plus 2 times 2 plus 4. Which gives us 1 over 4 plus 4 plus 4, or 12, so 1/12. So that's the limit as x approaches 2 of x minus 2 over x cubed minus 8. Our next example here, we've got a couple of ways to attack this. Again, we know that we have a factor in common. So the numerator, x minus 16, actually is a difference of squares, and that would be root x minus 4 and root x plus 4. So that would be one way to attack this, and then you could factor the numerator and you see the factor in common. The other thing that you've been taught is you could rationalize the denominator here by multiplying by the conjugate. We have a little announcement going on here. So are still out in the weight room, and you can have your picture taken. So we're going to continue through that announcement. One of the things we don't want to do in the numerator is distribute. So we're going to leave that. Here we go. We're done with that announcement. And now in our denominator, root x times root x is x. You end up with a 4 root x and a negative 4 root x. So that adds up to 0. Minus 4 times plus 4 is minus 16. So again, whether you broke it up into factors or rationalized the denominator there, either way, you end up with that factor in common of 1. So we have the limit now as x approaches 16 of root x plus 4. And applying our limit laws, the square root of 16 is 4, 4 plus 4, and we end up with 8. And here's one more example that we have to do some manipulation. Again, if we were to apply our limit laws, negative 3 here, we end up with 0. Negative 3 here, we end up with 0. Again, indeterminate. And so a pretty common strategy, and you've seen this before in solving algebraic equations with fractions, is you try to get rid of your fractions. And here what we have is what we call nested or complex fractions, fractions inside. So we're going to multiply by the numerator and denominator by the common denominator of 3x. Again, in our numerator, we are not going to distribute. Oops, that should be a 3x. And then here in the denominator, 3x times 1 over x is 3. 3x times 1 over 3, the 3's divide out, we end up with x. And then notice again, we have the x plus 3, the 3 plus x. There's the factor in common, so that divides out. And we're left with the limit as x approaches negative 3 of 3x. And again, applying our limit laws, that leaves us with negative 9. So again, here's 3 cases, all similar to some of the problems you've seen in this section of 1.3, where we have to do some kind of algebraic manipulation in order to determine the limit.